Hey guys, Miss Miklos here, and this lecture we are going to be talking about how to actually solve radical equations. And in order to solve radical equations, we are going to be combining a bunch of the concepts we've learned this chapter. And really this new thing that we're going to be talking about is called the powers property of equality. And the powers property of equality makes sense. We're used to knowing that if we have an equation, whatever I do to one side, I do to the other side. And this is basically saying the same thing. It says if A is equal to B, then A to the nth power equals B to the nth power. So it's saying that I can put an exponent in my problem. I just need to make sure that I raise both sides of the equation to the same exponent. Our directions today are going to say solve and check. And I underline check because I know often when we see check, we view that as being optional. And a lot of the times it is. It's just check for your own well-being to know you did it right. And today it's a little bit different because we need to actually check and make sure there are not any extraneous solutions. An extraneous solution is a false solution that may come up when both sides of the equation are raised to a power. And let's just think about it for a moment. We've kind of learned that the degree of a polynomial dictates how many possible solutions there will be, how many zeros we have, we've said. So if originally I just had x and then all of a sudden I square both sides, there could be adding in a degree of 2, which could create an extra solution that doesn't actually work. So basically, once I get my answers, I need to double check them into the original equation to make sure that they are indeed solutions. Okay, so number 1, we have x minus 4 equals the square root of 2x. And kind of the general things we're going to be doing today. First, we want to isolate the radical in our equation, which in this case it already is. Secondly, I want to get rid of this radical by raising both sides to a power. So in this case, I need to think what will eliminate a square root, and what eliminates a square root is squaring both sides. So I'm going to go ahead and write x minus 4 squared equals the square root of 2x squared. And we know that the right side of our equation then becomes 2x. But this can become a little bit tricky because I know when I'm squaring a binomial, I actually need to FOIL that out. And that's probably the biggest mistake that people make on a problem like this. So when I FOIL, I get x squared minus 8x plus 16 equals 2x. All of a sudden, I have a quadratic equation. So I'm going to try and solve this by factoring. So in order to do that, I need to subtract 2x from both sides to make my equation set equal to 0. Now I need to think, are there any factors of 16 that add up to be negative 10? And I know negative 8 and negative 2 would work. So I'm going to go ahead and set both of these factors equal to 0. And I get x equals 8 and x equals 2. Now, unfortunately, we know we're not done yet because I need to double check both of these answers into our original equation. So let's start with x equals 8. So I get 8 minus 4 equals the square root of 2 times 8. Is 4 equal to the square root of 16? And it is, so I know that that is an answer. Then let's try 2. 2 minus 4 equals the square root of 2 times 2. Is negative 2 equal to the square root of 4? And it's not. This is what we would call extraneous. We're not going to write extraneous. We're not going to write it in our answer. We would only write x equals 8 as our solution. Some of you guys might be thinking, well, square root plus or minus, like this should be true. However, we only have a plus or minus in our radical when we are physically square rooting both sides of an equation. Here, the radical is already in the equation. It does not have a plus or minus in it. So for this problem, 8 is our only solution. So that one was actually kind of a tougher one. So let's look at this one, which is a little bit easier. First thing I want to do is isolate my radical. So I'm going to add 4 to both sides. And now I need to think, what could I do to undo this radical? And I'm actually going to take both sides to the 3rd power. And we can think of this really in 2 different ways. If I'm cubing this, this would give me 3 x's inside, which means I can take that out, and I'm just left with x. The other way I could think about it, and I'll kind of write this down below here, I know the cube root of x is like x to the 1/3 power, and then if I'm cubing that, I end up getting x to the 1st, because I know when I'm taking an exponent to a power, we multiply that. Either way we think about it, we end up with x. So I get x equals 4 squared is 64. So let's double check this. I would need to do the cube root of 64 minus 4 equals 0. And just a reminder, there are really 2 ways we could check this. We could do a factor tree, or what I personally think would be easier would be to use our calculator. And if we use our calculator, if you guys press the math button, one of the options is a cube root. So I can just go ahead and do that and put 64, and we will find out that that is 4. 4 minus 4 is equal to 0. So x equals 64 is our solution. Number 3 is pretty similar. So I'm going to go ahead and I'm going to add the 4th root of x to both sides. To undo 4th root, I'm going to take both sides to the 4th power. 5 to the 4th power is 625. If I double check this, 5 minus the 4th root of 625 equals 0. If I want to use my calculator, I'm going to go ahead and start by typing 4, because that is our index number, then math, and then there's an option where there's an x in the radical representing our index number. And what this will do, this will make it a 4th root. So if I had a 5th root, obviously I would type 5 math x root. And so that way I can go ahead and put any single index number I want into my calculator. And we end up seeing that this is 5, so I get 5 minus 5 equals 0. So 625 is our solution. Okay, let's do one that's a little bit tougher. 2 times x to the 3/2 power equals 250. The thing that looks strange here is that I don't have a radical, but we know that this x to the 3/2 power is like a radical. So that is what I want to isolate to begin with. Now, the most common mistake I see on this problem is people think that this 2 is being taken to the power, but I know it's not. If it was, we would see parentheses around it. So the very first thing I need to do to isolate my exponent is to divide both sides by 2. So I get x to the 3/2 power equals 125. Now, I need to think, how can I get rid of this 3/2 power? And the way that I'm actually going to do that is to take both sides to the 2/3 power. Now, the significance of 2/3 is that these are reciprocals of one another, and when we multiply them, I get 1, so I just get x. 125 to the 2/3 power, this would be like the cube root of 125 squared, which would be 5 squared, which is 25. Now, I started boxing this, but before I actually know that this is my answer, I need to double check. So in my calculator, I would do 2 times 25 to the 3/2 power, and I'm going to write this out for you. And I need to make sure to put my 3/2 power in parentheses. That's kind of the big thing on this. And when I do that, I would notice that this is a solution. It makes a true statement. Number 5 here, we have a radical again. So my goal is to get that all by itself. So I'm going to go ahead and add 4 to both sides. Now, in order to get rid of a square root, I'm going to square both sides. So I end up with 2x plus 8 equals 100. In this case, This is just a linear equation for me to solve. So I get 2x is equal to 92. When I divide by both sides, I get x equals 46. I need to go ahead and double check this. So when I put this into my calculator, I get the square root of 92 plus 8 minus 4 equals 6. Is the square root of 100 minus 4 equal to 6? And it is, so 46 is our correct answer. By the way, this double checking is something that you can totally do in your head. I don't need to see work on it. It's just something you absolutely need to do. If we had found that this was an extraneous solution, then our answer would have been no solution. Okay, so number 6 looks kind of tough because I have two different radicals. And I cannot combine these two because they don't have the same radicand, so I can't add them together. So what I want to do here is split them up. So I'm going to go ahead and add the 2 radical x to both sides. Now the reason why I wanted to split this up is because if I went ahead and squared this first step, I'd be squaring this binomial, which we know means we have to FOIL. And since I have all these radicals, it would just be a ridiculous mess that we don't want to have to deal with. By moving 2 radical x to the other side, all of a sudden this becomes a lot easier to work with. And I get 3x plus 2 equals 4x. This is 4 because it's 2 squared. Now I'm just going to subtract 3x from both sides, and I get x equals 2. So let's double check. The square root of 3 times 2 plus 2 minus 2 radical 2. Is the square root of 8 minus 2 radical 2 equal to 0? And that does make a true statement, so x is equal to 2. Number 7. Once again, I have a radical. This time, it's already isolated, so I'm just going to go ahead and square both sides. Key thing here, once again, is this is a signal to me that I need to FOIL. So I get x squared minus 6x plus 9 equals 4x. When I subtract 4x from both sides, I get x squared minus 10x plus 9 is equal to 0. So I'm going to go ahead and factor, and I need to think what factors of 9 add up to be negative 10. And I'm thinking negative 9 and negative 1. So I'm going to set these both equal to 0. And I get x equals 9 and x equals 1. So let's double check. Let's see what happens when we do x equals 9. Is 9 minus 3 equal to the square root of 4 times 9? So is 6 equal to the square root of 36? And it is, so I know that is a solution. If I check 1, 1 minus 3 equals the square root of 4 times 1. Is negative 2 equal to the square root of 4? And it's not, so that answer would be extraneous. Our only solution here is x equals 9. Our final problem is actually our most difficult. And the reason why this one is the toughest is because I have 2 radicals that we cannot combine, and it's not equal to 0. So my first step, I still want to split up my radicals. So whenever I have more than one radical, I want to split them up. I know I'm going to have to square both sides here. So I get x plus 3 equals 1 plus square root of x minus 1 times 1 plus the square root of x minus 1. And it is much easier to FOIL with these binomials than if I had tried to FOIL this in the beginning. So let's kind of color code this. 1 times 1 is 1. 1 times radical x minus 1 is radical x minus 1. Radical x minus 1 times 1 is radical x minus 1. And radical x minus 1 times radical x minus 1 becomes x minus 1 because we have a pair that we can go ahead and take out. So at this point then, I'm going to add my like terms together. So I'm going to add 1 and 1, negative 1 together, which cancel out. Then I have this x, so I'm going to have equals x plus 2 radical x minus 1. And the problem that you guys are seeing is our radical is still here. So we actually need to go through this process again of isolating our radical. So I'm going to subtract x from both sides, and I get 3 equals 2 square root x minus 1. And then when I divide by 2, I get 3 halves equals the square root of x minus 1. Now that my radical is isolated, I'm going to square both sides. And I get 9/4 equals x minus 1. When I add to both sides, I get 13/4 equals x. So let's double check this. 13/4 plus 3 actually becomes 25/4. 13/4 minus 1 becomes 9/4. So is 5 halves minus 3 halves equal to 1? And it is. So 13/4 would be our solution. So when we see that we have two radicals and we have a binomial, we know that we're going to have to go through the process 2 times. So have fun solving. Make sure we're checking our answers, making sure that we're not giving any extraneous solutions as our final answer.